Welcome to all to our weekly sessions. We will be doing 10 problems every week. So this is the first presentation where we will discuss 5 problems. We will begin with a quote by Feynman. Feynman says that study hard what interests you the most in the most undisciplined, irrelevant and original manner possible. Problem number 1. If P is a constant vector and A is equal to half B cross R, evaluate del cross A. So these type of questions where the problem is focused on curl, divergence or any of the identity relations in mathematical physics could be a possible problem in CSIR. So let us discuss the answer to this problem. So let B is equal to Bi plus Bj plus Bk. R is equal to Xi plus Yj plus Zk. Then according to the question, A is equal to half B cross R. Substituting the values, we get A equal to half into Zp minus Ybi plus Xb minus Zbj plus Yb minus Xbk. Finding del cross A, we get determined Ijk dou by dou x, dou by dou y, dou by dou z, x component of A, x component, y component of A and z component of A. Substituting the values, we get answer as del cross A is equal to B. Now coming to problem number 2. This question was actually asked in 2015 December. In the scattering of small elementary particles, the scattering cross-section sigma is found to depend on the total energy E, fundamental constant h, where h is Planck's constant, and c, speed of light in vacuum. Using dimensional analysis, we are asked to find the dependence of sigma on these quantities. We have to understand what is sigma. Sigma is scattering cross-section. It is the effective area that quantifies the intrinsic likelihood of a scattering event. So its dimension should be L square. Now the dimension for Planck's constant is m L square T raised to minus 1. Energy is m L square T raised to minus 2. And that of speed of light is L T raised to minus 1. So sigma should be Sc by E whole square so that the dimension becomes L square. Hence the answer. Now coming to question number 3. If y is equal to 1 by tan hx, then x is, this is also a CSR question in December 2015. So given y is equal to 1 by tan hx. So tan hx is equal to 1 by y. Now we know tan hx is equal to sin hx by cos hx. Substituting the trigonometric relations for sin hx and cos hx, we get tan hx is equal to e raised to x minus e raised to minus x divided by e raised to x plus e raised to minus x. Dividing throughout by e raised to minus, we get e raised to 2x minus 1 divided by e raised to 2x plus 1 equal to 1 by a. Solving, we get x is equal to log root of y plus 1 by y minus 1. Now let's move to the problem number 4, where we are asked to find the poles of the function z by sine pi z square. So this is a frequent question in every CSR exam. So it is a must that we concentrate on poles and residues. Now in this case, z is equal to 0 is definitely a pole. Check how z is equal to 0 is a singularity. Limit z tends to 0, z by sine pi z square gives 0 by 0 form. Now we can apply L'Hospital rule. So we'll get limit z tends to 0, z by sine pi z square equal to 1 by 2 pi z. So it is clear that z is equal to 0 is a pole of order 1, hence a simple pole. For the function is f of z is equal to z by sine pi z square, there are also other poles. Now to find that, we equate pi z square equal to m pi. So m can have values both positive and negative values, that is plus or minus 1, plus or minus 2, plus or minus 3, etc. So z can have a value root n. But in the question, n is given as 1, 2, 3. So if m is equal to n, z is equal to plus or minus root n. But there is also another possibility that m is equal to minus n. So z is equal to plus or minus I root n. Pole of order 2 at plus or minus root n and plus or minus I root n for n equal to 1, 2, 3, etc. Now coming to the last question in the first discussion. Here is a CSR question in 2015 December, where we are asked to find the Fourier transform of a function f of x is equal to alpha delta x plus beta delta prime x plus gamma delta double prime x, where delta x is Dirac delta function and prime denotes the derivative. So question is, what is f of k? To solve this problem, we should know the property of a delta function, that is integral minus infinity to plus infinity dx e raised to ikx delta x is always e raised to ik0, that is equal to 1. Now we are asked to find the Fourier transform of f of x, where it contains delta x, delta prime x as well as delta double prime x. So we individually take each one out and solve it out. So let us first consider alpha delta x. The Fourier transform of alpha delta x is alpha, and in order to find the Fourier transform of beta delta prime x, we had to integrate by parts one time. It is very clearly shown in the slide, and it gives the value minus I k beta. Now considering gamma delta double prime x, we get the Fourier transform as minus k square gamma. So the Fourier transform of the function becomes alpha minus I k beta minus k square gamma. So Fourier transform is asked very frequently. So it is advisable that students learn both Fourier transform as well as Laplace transform for some standard integrals, and also clubbing some basic functions like delta functions, gamma functions and beta functions could be very helpful in working out some problems related to mathematical physics in CSR exams. Let us end with a quote. The quote goes like this: you must trust that your beliefs are unique, your own, even though others may think them odd or unpopular. Thank you for patiently listening.